Okay, so on the video last night, the mistake that I made is I said plus 1 was 3/2. And then instead of writing divide by 3/2, I wrote divide by 2/3, like I had already flipped it in my head. And then when I flipped it back up and said 3/2 in the front, and that was wrong. So if you're looking back at your example 1, that's where the mistake was in the video, because I accidentally flipped and then flipped again.
And for number 2, you added the plus C.
Well, did I miss the plus C on number 2?
No, I might have missed it.
Oh, okay. No, I think I had the plus C in there. Okay. So we went through example 5, right? Okay, so now we're looking at example 6. And hopefully I am done making mistakes. Okay. Okay, so the first thing we need to do is figure out what we could call the inside of the function and then what we call the derivative of the inside of the function. Okay, so for number 6, what part looks like it's probably the inside? Okay, so u is the square root of x plus 7. When I take the derivative of that, I'm going to have a hard time with that square root. And so I'm going to call this x to the 1/2 plus 7. So when I do du, when I take the square root of this, what do I have? 1/2 x to the negative 1/2 dx. Only this is not how it's going to show up in the problem. How is it going to show up in the problem?
As a fraction.
Yeah, it would be 1/2 square root x dx. But do you see a 1/2 square root x? Yeah, I see a 1 over square root x, but I don't see the 2. So how can I get rid of the 2? Yeah, so I'm going to say multiply this by 2 and multiply this by 2.
What do you mean by you don't see a 1/2 square root?
I don't see a 2 in the problem. I see a square root x on the bottom of the fraction in the problem, but I don't see a 2 with it, which means that I have to take that away from my dx side. So this part right here, anything in terms of x is supposed to actually show up in the problem, and it did not. So that's why I had to get rid of it. So what that means is that 2 du is what will represent 1 over square root of x dx. So now I can go ahead and rewrite the problem. So I've got, this is what we plugged u in for. So I've got u to the 8th. And the 1 over square root of x dx is being represented by 2 du. So this is times 2 du. And we don't want a coefficient hanging out in the middle of the problem. So what should I do with that 2? Move it to the front.
Does it matter if you move it to the front of the integral or in front of the u?
You could move it to the front of the u if you wanted. Or in front of the integral. I'd say, like, traditionally people move it to the front of the integral, and my answer keys will probably do that, but you're not going to get the answer wrong if you move it just to the front of the u.
So on the AP exam, they don't mind that.
No, not at all. All right, so what do we do now that everything is in terms of u and has been simplified and all that? Now we're doing the antiderivative. We're actually taking the antiderivative, right? So we do the little rule, which is what? Plus 1 divide by 9. So we have the 2 on the front, and now I have a divide by 9 that I'm pulling out as a 1/9, u to the 9th plus c. We're going to have growing pains today. It will get better because we're going to do it a lot. Yeah.
Where does the S go?
So the S, remember, is saying it's the command of, like, do the antiderivative.
Okay.
So once I do the antiderivative, I don't write it anymore because I've undone that operation. It's gone. It's the idea of an inverse operation. So when I do the antiderivative of a derivative, I just get the original function. So I undid that operation, now I'm done. Yeah. So I have 2 times 1/9 u to the 9th plus c. So 2 times 1/9 is 2/9. What was my u?
What happens to the square root of x plus 7?
The du is gone because that's part of the undoing the integral. Okay. U was square root of x plus 7, so it's u to the 9th plus c on the end. Okay. I think maybe we should start practicing some of these because I think the next couple examples might make you not happy if you don't practice before you get to them. Okay? So I think we're going to pause our notes there. How many more examples? 3. All right. So turn to page 337. All right, turning to page 337, we're looking at number 5. All right, we're looking at number 5. Okay, so go ahead and take a moment and write number 5 down. And we need to figure out what the inside would be. So I've got u is 1 plus 6x. And the derivative of u is 6 dx. Okay. So we were asking, some of us were asking, like, what's the point of the du if you don't actually plug it in somewhere? And the answer is you do actually plug it in somewhere. So this part right here is the u. Do you guys see that? That's u to the 4th. 6 dx is the du. Do you see it? So now that I've said u equals this stuff and du equals that stuff, then that means that when I put this problem in terms of u, all I have is u to the 4th du.
Yep.
And the u stuff absorbed everything else.
Yeah, but then when we take the derivative, the du just disappears, so I can never plug a value in.
It always disappears. Remember, the number on the end just represents the width of the rectangle, and you never actually did anything with it. Yeah, so when we actually do the antiderivative, the du never had a part, the dx never had a part, the dt never had a part. Yeah. Okay, yeah.
So, like, you're having to be u also because if it needs to be divided by 2 or something, then that would go into
Yes.
the other thing you do later.
Yes, we find the du just to make sure, because the du represents the derivative of the inside, that's the chain rule part of it, and we have to make sure that the derivative of the inside is there exactly, and that if we need to make adjustments, that's the time where we figure out what adjustments we need to make.
Okay, then that would go into the
Yes.
final one.
Yes, yeah. All right, so now if we use our antiderivative rules with this, what do we do?
5 plus 1.
Yep, so 4 plus 1 divided by 5. So we've undone the integration, so we did the antiderivative of the derivative, and that gives us 1/5 u to the 5th plus c. And then what do we do? Plug in the u.
Why did you have to like divide anything? Because that's what du actually is.
Yeah. Well, I pulled out this divide by 5. I pulled it out as a 1/5.
No, like when you before you did like du, you usually had like to divide by something. Why did you?
Oh, because the derivative exactly was written there.
Okay.
Yeah. All right. So the u was 1 plus 6x to the 5th plus c, and we're done.
How do you know when to stop?
When you're integrating, once it's all simplified and you're ready to just plug the u in.
Are we able to find C in these types of problems? Like
You're only able to find c if they give you a point on the actual graph. So if they say this represents f of x and f of 1 equals 5. You can't find c without having a value to plug in. All right, number 7. Number 7 says integral of square root of 25 minus x squared times negative 2x dx. So if you're comfortable with the problem so far, like if they make sense to you, you can quietly just continue working. If they don't make sense, we'll keep doing them until we're good. Okay? So what's the inside function? So you have two options. You have this inside or this could be inside. And you have to remember there's two parts, right? We take the inside and then we find the derivative of the inside. Okay? So if we chose negative 2x to be our inside, then what would the derivative of negative 2x be? Negative 2, and that's all that we would be looking for in the rest of the problem, and you can see that the rest of the problem is a lot more complicated than that. So that means that if you chose your u to be negative 2x, then you could not complete the problem. So that means that's the wrong u. So if this is not u, then this must be the u. Does that make sense how I think it through? So make sure whatever you think of as the inside, that you can find the derivative, because you're looking for one thing to be the inside and you're looking for the other thing to be the derivative of the inside. Okay, so that's how you choose what your u is, okay? And the more you do these problems, the more you'll get like a sixth sense of what the u should be and what should not be u, okay? And that's the purpose of all this practicing, is to get better and better and better at choosing the u. So if u is 25 minus x squared, then du is negative 2x. And we can see that this right here is our u, and then this all right here, sorry, negative 2x dx, this all right there is exactly our du. The negative 2 and the x, it's all written there. So this is our du.
And we don't include the square root because we're only looking at the inside of the square root.
Yep.
Okay.
So the square root is our outside function, and that's okay. We're going to deal with that as part of the problem. So that's going to leave us with the square root of u du, and I need to rewrite that so that I can deal with the exponents. So what should I write? Yeah, so square root of u to the 1/2 du.
And then 1/2 plus 1.
So plus 1, divide by
3 halves.
3 halves.
And now we can
Rude. All right, so now what do I have? U to the 3 halves plus c. So I've simplified it, right? And now I can plug the u in, and then I'll be finished because I'll have plugged the u in. Now, at this point, this is an acceptable answer, but if you were doing a multiple choice problem and every single answer had a radical in it, then what would you do? Yeah, you'd rewrite it to make sure this was a square root of the parentheses to the third. So you could rewrite this problem. At this point, we've practiced that enough. I'm not going to say we have to do that every single time. But we do know that the multiple choice answer could have been in another form, because there is a way to rewrite this in a different form. So if they had written it as a radical, it would have been 2/3 and then the square root of 25 minus x squared, and they could either put parentheses around here and put third right there, or they could have put parentheses around the whole thing and put third. All right? So it could have been written either way. Okay. Do we need to keep going together, or are we feeling more comfortable? One more? Okay. So if you're working on your own, that's fine, but you got to be mostly quiet because it's starting to get louder in here. We still have some people who want to see another example. So work silently on your own if you're working on your own. And then we're going to go ahead and do number 9. So this one says integral of x to the third times x to the fourth plus 3 squared dx. So what would the u be? X to the fourth plus 3. So du is 4x to the third plus 0, right? Dx. And when I look at the problem, I do see the x to the third in the problem, but I do not see the 4.
Okay.
Divide the 4 over. Okay. So for my integral, this part right here is the u. So here's my u right there. So I've got u to the second. And then x to the third dx is going to be represented by du over 4. So x to the third dx is represented by du over 4. Okay? How are we doing with that part? So these two terms that are, so this term was represented by the u, so I've got u squared, and then these two parts that were left over are right here, x to the third dx, and so that's the same as du over 4. So I kept the u squared, I kept the du over 4. Now, are we going to leave that du over 4 as du over 4? No. We're going to pull it to the front, okay? And so do I just put a 4 in the front? A 1/4. Okay, so I've got 1/4 u squared du, and now I can use my rules. So what does my rule say?
Add 1 to the third.
So plus 1, that's to the third, divide by 3. So I already had a 1/4 in the front. What does the divide by 3 do? I got a 1/3 in the front now as well. And I have a u to the third plus c. So I have a little bit of simplifying that I can do. That's 1/12. I'm gonna go ahead and keep writing it in terms of u. At that point, with the 1/12, if you were comfortable, you could replace the u if you wanted. Okay, you're not wrong to replace it sooner. As you do these problems more and more, you'll get more comfortable with showing less work. But when you first learn something, I find students usually make less mistakes when they show more of their work in the beginning, especially. So I went ahead and I multiplied those fractions. Now that it's completely simplified, I'm going to go ahead and replace the u. And so I've got 1/12, and what should I put in for u? And that u is to the third power, and then I have to have my plus c on the end.
Man, this is always about you.
Ba-dum-bum. All right. Do another one, or are we more set? One more. What we're going to do is we're going to practice the beginning of the assignment. The trig ones happen a little bit later. So once we start to get to the point where we're comfortable, then I'll get us back together and do some more examples. Okay, so let's do number 11. We have u squared, not u squared, x squared, times x to the third minus 1 to the fourth dx. All right, so what should we call u? And then that would mean that du is, okay. And when we look at the problem, do we see the whole derivative outside?
No 3.
No 3. So we're going to divide by 3 and divide by 3. So that means that this part right here is the u, and the x squared and the dx is the du over 3. So our integral is u to the fourth and du over 3. So u to the fourth and du over 3. So what do I do? Pull out the 1/3, u to the fourth du. And now what do I do? Add 1, so we're doing the antiderivative. Add 1, divide by 5. So we already had a 1/3 out in the front. Now what else do we have in the front? A 1/5. U to the 5th plus c. I do have a little bit of simplifying that can be done. 1/15 u to the 5th plus c. Anyone remember why I'm writing arrows and not equal signs?
Because they'll count it.
Yeah, because they'll, if you made a little mistake somewhere in here, they would have counted the whole thing wrong on the AP exam. So we draw arrows so that we're showing we're simplifying just in case we make a mistake somewhere we can get partial credit. Okay. So this is 1/15. The u was x to the third minus 1 to the 5th plus c. What could you do to check your final answer if I didn't give you an answer key? Yeah, take this, find the derivative, and see if it matches the original problem.
And the plus c always goes to 0.
Yeah, it represents a constant, which is a number, and the derivative of that would always be 0. Yeah. Okay. We feeling better? Okay. So here's the assignment. It is a long assignment, I'm not going to lie. The video tonight is not, it's I want to say it's like 16 minutes, but it's not going to be mentally strenuous, not after today. I think the video tonight is about using U substitution, but doing it with a couple other types of functions with exponentials and logs. So I think it's not much of, it's a little bit of a continuation today, but I don't think it's going to hurt your brain like last night did. Okay, so we'll see how far we get on this. I'll cut down the assignment if I need to. Okay.
How do we do the du for 15?
So for 15, you just divide the -2 over. So
It's a 5.
I already took, so what I did is I took the 5 out before I even got started with the u. See that? I took the 5 out. Because you can, right at the very beginning, you can take the 5 out and ignore it. And so then my derivative is just x, right? And I need to take out a -2. So I end up already having a 5 taken out. And I take out a -1/2 as well, so I have a -5/2 out. Yeah. All right. So this is number 7 for your examples. So these are back on our notes. And I just want to do 2 trig examples because you're going to see that identifying the inside and the outside might feel a little bit different on these ones than it did on the other ones. So this example is sine of sine x. So this is not, I'm not multiplying sine times sine. I'm saying that this sine has another sine inside of it. Okay? So outside function, inside function, times cos x dx. Okay, so what is the inside function? Sine x. So u equals sine of x. Then what is the derivative of u? Cos x dx. We don't divide by cos x, and you'll actually notice the only thing that you can move over to the other side with a du is a number. That's what we'll talk more about later, is what happens if the derivative isn't there and you still have some other variables in the problem. We'll be able to deal with that. But for right now, we won't have any problems like that, okay? So I can see that sine x is the inside. Here's the inside function. Here's the outside function. Here's the derivative of the inside function, okay? So that means that what we have is we have sine of u. Here's our u right here. And then cos x dx is our du. Okay, so that means that what I actually have is sine of u, and then this is all du.
So we choose the sign like it was a early variable, like
Outside function.
a, yeah.
Mm-hmm. Yep. Okay. So the antiderivative of sine is negative cos. So this is negative cos of u plus c. And then we can go ahead and plug our u in. So we get negative cos of sine x plus c. And if you need to check it to see if it's right so it makes more sense in your brain, that's fine. So if we think about this problem, the derivative of the outside, the derivative of negative sine would have been positive sine. Keep the inside the same. Multiply by the derivative of the inside, which is cos, and then plus 0. So that really does fit. Okay. We'll go ahead and do one more. So example 8. Sine x times cos of, so this is the outside function, the inside function is going to be cos x plus 2. So the inside function would be cos x plus 2. And the derivative of the inside is negative sine x dx. And I do see most of that outside, but I don't see part of it. I don't see the negative 1. So I'm going to divide by negative 1, divide by negative 1. So when I rewrite the problem, I have cos of u, and then the sine x and the dx are represented by du over negative 1. So the sine x and the dx are represented by du over negative 1. Do I want to leave it written like that? No, what should I do? Okay, so I'm going to pull a negative to the front. I've got cos of u du. And the antiderivative of cos is sine, right? And I already had a negative in the front. So I've got a negative in the front, and then the derivative of cos is sine. And you don't really have to write it with all those parentheses. I just want you guys to know that the negative came because there was a negative in the front. And the antiderivative of cos is just plain sine. It's not a negative sign, it's just sine. Yeah.
When you did U and DU, how did you get negative sign, and how did you get sign here?
So the derivative of cos is negative sign.
Okay.
And there wasn't a negative sign in the original problem. There was just a sign. So I had to divide by the -1. So that's why I have a du over -1.
How did you get just sign for?
Because when I do the antiderivative of cos, I have to think about what did I take the derivative of originally
To get cos.
to just get cos, and what I would have taken the derivative of originally would have just been plain sine.
Would we have gotten the same answer if we had put the negative in front of the sign rather than the integral?
Yeah. Yeah. Yeah, like if you had taken this sign and left it right here instead. Yeah, you would have been fine. Okay, those are all the examples I have for you for today. We're going to have one more, but we're going to do it tomorrow when we are less overwhelmed. Okay? Yeah.
Which ones are we not doing?
You, of the original assignment, you're just skipping 61 through 65 for today. These ones here, the 69 through 75, those are practicing U substitution with a definite integral, where you have the numbers in there. And then 93 is actually going back and having you do some properties of integrals, just because I want to make sure you guys haven't forgotten those. So I think 93 is okay.
Can you
Yes.
walk us through 69?
Yeah, we can do 69. That was a weird way to phrase it, but we're okay with that.
Do you mind?
There was no good way to phrase it.
Is number 23 easy enough for us to not walk through? Because I'm having trouble with it. But yeah, it's got the 1 over t plus 1.
Yeah, just the inside is the u, and then just do it the way, just walk through the problem, making sure you take the derivative of everything correctly, and I think you can do it on your own. But I can come over and help you in a second if you want. Okay. We're gonna do this problem. Hey guys. We're going to go through this problem because it would be good for us to do another problem where we're doing a definite integral with U substitution. So I just want to make sure we're okay with this before we leave. So -1 to 1 x times x squared plus 1 to the third dx. Now this problem, when you do it, the U substitution should be pretty comfortable for this problem at this point because we've done some more difficult problems. The part that we're going to be concerned about is that interval from -1 to 1. That's the part we have to watch out for. Okay, so if we're just doing the U substitution part to get started, what's the U?
X squared plus 1.
Okay, U, x squared plus 1. Du,
Divided by 2.
okay. So I'm going to say that I've got u to the third, and then the x and the dx are represented by du over 2. And then I'm going to go ahead and pull out that 1/2 just like normal. So 1/2 u to the third du. And so the actual integral part of it is ready to go. Now we have to deal with the fact that we have this evaluation piece. So the -1 and the +1 are in terms of x. We have to switch it over so that it's in terms of u. Does anyone remember the trick to that from the video? Plug it in. Yeah. So we're going to say u of +1 is 1 squared plus 1, which is 2. And u of -1 is -1 squared plus 1, which is also 2. We actually know this answer before we even get started.
0.
Yeah, it's going to be 0. So the integral is from 2 to 2. So if we could complete the problem anyway. That's the only thing that makes it different, though, is that you just have to figure out your interval in terms of u instead of in terms of x. Yeah. Yeah, we can go through and just finish it. So plus 1 divided by 4. So we already had a 1/2 in the front. Now we also have a 1/4 in the front. And we've got u to the 4th. And instead of putting the plus c, we're going to show that we're evaluating it from 2 to 2. And then I'll go ahead and just simplify a little bit before I actually evaluate it. I'm going to say I've got 1/8 u to the 4th, evaluated from 2 to 2. And when you're doing a definite integral with u substitution, you never plug the x back in. You just leave it in terms of u because we just switched our interval to be in terms of u. So you leave it in terms of u, and now we can plug in the upper bound minus the lower bound. And this is where we know it's going to zero out because we have 1/8 times 2 to the 4th minus 1/8 times the lower bound 2 to the 4th. And we're subtracting the same thing, and we just get 0. And you can check these answers by taking the original problem and plugging it into your calculator and making sure you get the same answer. I didn't do this problem ahead of time, so I'm really hoping I didn't make a mistake there. Let's double check.
Just take a step back.
So if you can see, I went ahead and I plugged in the original problem exactly the way it was written, and I got 0. Okay?